So, what do you want to start with, physics or math? Let's have show of hands. Who wants to start with physics? Who wants to start with math? Physics it is. You should have voted, guys. Okay. We're starting with physics. Okay, so let's go through the physics homework. So the first one, 28. Lincoln, what do you have for 28?
Looks like for A, I have 3.33 meters per second squared. And for B, I have the time as 36 seconds. And for the distance, it's 720.6 meters.
Okay, let's go through it. So for 28, your V0 was 0. We're using the V squared equation. So the acceleration, therefore, is V squared over 2 times the distance, which should be 1.67. If you didn't get it, just fix it. How many of you got it? Okay. The next one was 30. Jessa, what do you have for 30? Oh, wait, let me show B first. And then in B, you had to get your time. It's 12 seconds. And then this was 240 meters. Okay. 230, Jessa.
For A, I got at 4 seconds, I got 2.5 centimeters per second. And for 7 seconds, I got 1.5 centimeters per second. And then for B, I got negative 1 centimeters per second squared for all of them. And then I got 22.5 centimeters for C and 28.5 centimeters.
Okay, I think everything's just off by a little, I think, from when you're reading the graph. So for the first one, we know that the acceleration is the slope. So find the cat's velocity at 4 and 7. You're just reading that from the graph. Okay, so I have here 2.7 and 1.3. So if you're, within the ballpark close enough, because you were kind of eyeballing it. And then the cat's acceleration at 3, okay, you're getting that slope. Now, all of you should know how to get slope. You've done it 100 times, if not more. It comes out to negative 1.3. Now, you might be off by a little bit, but you're changing y. You can just pick any 2 points on that graph, so you can go from 0 to 8 for your change in y, and then you're changing time like 5.8. Now, since we know the acceleration, what distance does the cat move during the first 4.5 seconds? Okay, so we can just use our distance equation. You could have also gotten the area under the curve, okay? Either way. They're using the distance equation here to get 22.8 from 4.5 and 23.4 for 7.5. Now, if you got the area under the curve, you should have gotten similar numbers. You would have had a trapezoid and a triangle. Did anyone get all of them? Do you understand? Just fix it if you didn't get it. Okay. So if you're just having problems reading the graph and you're off by a little bit, so your numbers are all off by a little bit, that's fine, but you should understand the concepts. Area under the curve using the distance equation. 32, Tori?
For A,
oh, wait, sorry, I didn't show the graphs. Okay, these graphs are an important part of this subject so that you understand what's happening. The acceleration is a straight line, a flat line, because we have uniform acceleration. and X is a parabola. You're going to see these parabolas and flat lines, so often, including on the AP test. All right, so if you didn't get those graphs right, write that down. Now it's a negative, so it's down here at negative 1.3. This is going up, coming back. Okay, slowing down, turning around. So the acceleration versus time is very simple, just a horizontal line. The position versus time is a bit harder. Okay, did you get it? All right, Tori, what were you saying for 32?
Okay, so for A at 0 seconds, we got distance of 4, velocity of 4, and acceleration of 0. And then at 1 second, distance of 4, velocity of 4, acceleration 0. 3 seconds, distance 11, velocity 8, acceleration 0. And then for B, I got at 0 seconds, a distance is 0, velocity negative 3.7 meters per second, and then an acceleration of 0. And for 1 second, distance of 4, the same velocity, and for 3 seconds, a distance of 11 and the same velocity. And then for B, I got at 3 seconds and at kind of 1 second, like 0.9 seconds.
Good.
And then C, I have 2 graphs.
Okay. Did you get D? At what times, if any, do they have the same velocity?
I put that.
Okay, anytime their slopes are the same, they're going to have the same velocity. Can you see anywhere that those two curves seem to have the same slope? Anybody? Where do those curves have the same slope?
1 and 3.
Well, no, they intersect there, but their slopes aren't the same. Where are their slopes the same?
At 2.
At 2. Okay. So you can see they intersect at 1 and 3. So what times do they have the same position? That's obviously at 1 and 3. They have the same velocity when they have the same slope at 2. Then E, at what time, if any, does car A pass car B? That's also pretty clear, right? When does that happen? 3. Right, 3 seconds. Does car B pass car A? That's at 1 second, okay? All right, these are your diagrams right here. So for A, your velocity is 0, your acceleration. B, your acceleration is 0, but we have velocity. At 1 second, we have the same acceleration here. This is your velocity of A, velocity of B has 0 acceleration. At 3 seconds, A is moving faster. Okay, so these graphs are harder than looking at something on the ACT, so they make the ACT graphs in the science section look a whole lot easier. You can see that if you look at that slope, that in the beginning, B is the faster one. So show the position, velocity, and acceleration of each of the two cars at 0, 1, and 3. Okay, so there you have this graph right here of velocity. Notice that B has uniform velocity, right? Because it's a straight line. Whereas A has this constantly changing velocity. So the velocity of A is constantly changing. The velocity of B is uniform. You should have been able to figure that out from the graphs. So the velocity of B is never changing. So they have the same velocity for B throughout. The velocity of A is becoming more and more. So you should have a motion diagram that the vector is getting longer and longer for A. The acceleration is 0 for B. So it's always 0. We have uniform velocity here. The acceleration is uniform, so our velocity is becoming increasingly bigger. So your acceleration for A should have always been the same. Your acceleration for B should have been 0. Your velocity for A should have been increasing. Your velocity for B should have been constant. If you put the work into this class, it'll help you so much intellectually, not only on that ACT. It'll help you in any subject because physics involves so many areas of thinking. So whatever you go into, if you put the work in, now I say you put the work in, you have to read the book. If it reinforces the learning, and you should read the calculus book. Otherwise, you just are forgetting everything and not understanding it as deeply. There's only so much I can do in material this hard. If you're talking about something that's really simple, maybe you don't need to do anything outside of class. You're talking about something harder like this, you need to put the work in outside of class, not only doing your homework, but trying to understand it, read the textbook, etc. That will help you in anything, even if you're an English major or a psychology major, whatever it is. It helps your reading skills. You need science in it, just about everything these days, except for English. Okay, you need science in psychology, economics, everything. And there are graphs in everything, every social studies. Okay, 34. They made 32 a 1-dot problem, but really 32 was probably, I thought it had its challenges. 34, Connie.
For A, for A, I got 71.4 meters, and for B, I got 7.1 seconds, and for C, I just figured
Okay, let's go through it. So one car starts from rest. All right, that's 1/2 AT squared is that equation. So this type of question is common. One is moving with constant velocity. Again, they're distinguishing between constant velocity and constant acceleration. So this one has constant acceleration, the car. The truck has a constant velocity. So those are two totally different things. So the equation for the truck right here is just VT. There's no plus 1/2 AT squared. The equation for the car is 1/2 AT squared. There's no VT. Okay, so we have that. Using that, you set those two equations equal to each other. We had this question in Physics 1. It's a very common question. It was in your SP problems. And they asked you the same thing. They had you plot data, and you could do it graphically. So I can cancel out this t, cancel out that t, solve for my time. Move up the 2, so I get 2v0 over a is equal to my time. Obviously, when one passes the other, they have the same distance. You can set those distance equations equal to each other. So you get 14.29. You plug in that time to get 286. You could have plugged it into either equation because they're equal at that time. Then they ask you the velocity. This is a very common question, 40 meters per second. You'll see it like in every textbook. When they get harder, they have one waits to start to accelerate. Did anybody get it? Okay, now we have these same graphs that we see over and over, like this, right? They look just like 232. The truck has uniform velocity. The car has uniform acceleration. So the velocity here is uniform. The car is constantly changing. This is the same graphs we were just looking at. Okay. Then you had 60 and 61. 61 wasn't that hard. You just had to get your area under the curve and then do the same old sketches. Lincoln, did you get 61? We'll do 61 first. That's the easier one.
For A, I got 132. For B, I got 132.
Okay. I have 92. Okay, so they're doing these equations, but you could have done area under the curve. Find the total distance moved during the first 12 seconds, okay? You can do a trapezoid and a triangle, or however you wanted to break that up. But if you did that area correctly, notice they're using this equation, but this is the equation of a trapezoid. A trapezoid is base 1 plus base 2 times the height divided by 2. So they're using the distance equation, but it is the same equation for a trapezoid, so it has the same effect. And then for 10 seconds to 12 seconds, they get 12, so the total is 92. How many of you got that one? Okay. So the total distance moved and the displacement. Okay, if something doesn't turn around, those are the same. So the answers for A and B are the same. It would have to cross the x-axis for them to change. Okay, sketch a graph of acceleration. We have as many accelerations as we have velocities. So you get the slopes of those lines, 0.8 and -6. So the first slope, you should have been able to see, you have 8 divided by 10, which is 0.8. So that was your first slope. The second slope, you guys should know well how to get slopes. Okay, 60 was the hardest one. Does anyone feel confident in their answer for 60? Okay, Connie.
I got 1,796 meters.
That's close. So from 0 to 14 seconds, we had 157 meters. At 14 seconds, we have this speed. And so in the next 70 seconds, we get 1,568. Then you had to do the interval during which the train is slowing down and get that distance of 72. So there were 3 periods you had to break it up into. And the whole thing, 157 plus 1568 plus 72 comes to 1800. Did anybody get it? Well, if you got a 3-dot problem, that's really good. Okay. We're going to do projectiles. So you've had all of this before, and you see the point of having it before. Do you remember projectiles? We're working in one dimension. That makes it a lot easier. Delta y is equal to, okay, we're talking only about things in the air along one dimension. So this can be plus or minus, depending on whether it went above the start point or below the start point. Plus or minus, depending on whether it's thrown up or thrown down. But this is always -1/2 9.8 t squared.
Are we gonna be working with one dimension today?
With what?
With one dimension?
Yes, only one dimension. This chapter is one dimension. Then the velocity equation, plus or minus v final, depending on whether it's going up or coming down. Plus or minus v0, depending on whether it's thrown up or down. And then this is always 9.8 t. And then we have now our v squared equation, v final squared. So that negative goes away when you square it, but you have to understand in the end whether it's going up or down. Again, if you take the square root to solve for the right side of the equation, you have to put in a plus or a minus. Minus 2 times 9.8 times delta y. Okay, so write those down. It's just the same equations, the distance, velocity, the v squared equation.
Throwing up, throwing down.
Yes, exactly.
That's the change in y variable.
Change in y, delta y.
What is delta y?
Just the change in y, like however many meters it
Okay.
traversed. The displacement in y. We also have that fourth one, delta y is equal to 1/2 v0y plus v final y times the time. That one comes up less commonly. That's just your fourth equation put in terms of y. Now again, this is a trapezoid. This is the equation of a trapezoid. So you're getting the area under the curve of the velocity graph by doing that.
What's that, what's in the parentheses?
Right here, v0y plus v final y. Okay, so again, this is a trapezoid. You're getting the area under the curve. 1/2 base 1 plus base 2 times the height. The height is t. These are the bases of the trapezoid. You would have learned your trapezoids in geometry, right? Okay. So we're just going to take these same equations, so you should have them all written down in front of you. Plus or minus, if you pick out if something's thrown up, you have to remember you're making that a positive. If it's thrown down, you're making that velocity a negative. Your acceleration never changes. It's always negative 9.8. That makes that problem easier. Okay, so let's start. We're going to maybe start with, I had in mind we were doing math first, but since 2 people voted, now I had to change that. Okay, we're going to start, I think, with the 1 dot problems initially. Everybody wrote this down, right?
Yep.
And then maybe work our way up to 2 dot problems. So let's start with um, 35. Let's start with 37. That's a 1 dot problem. Violet, could you please read 37?
A jumping throws a bowling pin straight up with an initial speed of 8.2 meters per second. How much time elapses until the bowling pin returns to the person's hand?
Okay. Let's see how much you remember. This is a physics 1 problem. Write down what variable they give you. There's there's different ways you can do this. Write down what you know. See if you need to remember something from your physics 1. Let's see if you remember it. You can do this 2 different ways, probably more than 2 different ways, but you have to think about the problem. So depending on which approach you take is how you're going to do it. There's other information there besides that initial speed.
We're doing 37.
What?
We're doing 37.
Yes.
Okay, switch. See if they can have the board.
What are some other things you know there? From that information, what else what are other things you know?
Then it's going back to school.
Right, so what is that? What variable, what does that tell you?
Final velocity 0.
Actually, it wouldn't be, right? It's going to hit his hand with the speed.
Well, it is my idea afterwards,
What does that tell you if it returns to his hand? What variable do you know in that situation? Right, but what variable? What number is that variable? What variable? It tells you a variable and the number of that variable. Doesn't tell you the speed. I mean, we actually know the speed it hits his hand, but because we're ignoring what? We're not talking about forces here. Like in our 4 equations,
what's in the way.
Anybody? Naomi, can you tell me? Distance is what? Displacement is what?
Oh.
0. The displacement is 0. What is the final velocity going to be? No, that's the acceleration. What? Right, negative 8.20. We know it's going to hit at that same speed because we're neglecting air resistance. You also know something else. What's the speed at the high point? 0. Using all that information, you can figure this out. You can do it in one step and solve right away, or you can do it in 2 steps.
Since it could that come down the final speed to the second.
Right, except it's negative. So we know our delta y is 0. Show me if you get it.
So is the initial and the final velocity 8.2?
Yes. But the final is negative 8.2. So you can use your displacement equation, you can use your velocity equation, but you have to use them in different ways. I know the delta y is 0, so if I use the displacement equation, it's like this. This is one way to do it. I have a delta y 0, my initial is 8.2t minus 1/2 9.8 p squared. You know how to solve that algebraic equation. It's a quadratic, but you don't have to use the quadratic formula because there's nothing on the left side. That's one way to do it. What's another way? Who did this in physics 1? Can anyone tell me another way? Use the velocity equation and get what? Time to what? You can get time to the high point and then double it, or you can get time for the entire trip. So we know our final velocity at the high point is 0. We know our final velocity when it comes back down to the ground is negative 8.2. You can use either one. So there's 3 ways you can do it, and there's probably more ways. Connie, did you get it? Good. Which way did you do it?
I use the velocity and use the final.
Okay, good. We can do it like this. The Velocity at the high point is 0 and get 0.837 and then double it. We could have also made the final velocity negative 8.2. Right? That was a third way we could do it. Negative 8.2 is equal to 8.2 minus 9.8 t. And then gotten that time. You can do it any of those ways. Remember? Okay. Are there any questions? Coming back to you. This is great review for your final. Okay. Now we're going to go to a 2-dot problem. So let's go to 235. Connor, can you please read 235?
If a flea can jump straight up to the height of 0.440 meters, what is its initial speed as it leaves the ground? How long is it in the air for?
Okay, write down what they give you. Now you know more than that 0.44. You have to figure out what else you know. And then write down what they're asking you to get. Then think about which equation you're going to use. It doesn't mean that there's just one way to do this. Look at your set of equations.
Is it just jumping straight up?
Yes, it's just all of these are one-dimensional. So they told you your delta y is 0.440 meters. You can do it in one step, you can do it in 2 steps. But since they ask you the 2 questions, you don't really lose anything if you do it in 2 steps. What do you know besides your delta y and your acceleration? One more thing you know. What's the v final? 0. Anytime you go to the high point, your v final is 0. So you know that too. If you use your distance equation, you have the unknown of the time and the unknown of the 0. So you can't use your distance equation to solve the initial speed. What equation should we use?
Is it changing y just to changing distance?
Yes. What equation should we use? V squared. You don't know time, use the V squared equation. Once you solve for that, then you can figure out how long is it in the air. Once you get that V0, then you can solve. Anybody get their V0?
If you use the final equation, you get to double it.
It depends what you're looking for. If you were looking for the time to go up and come down, you double it. But if you're only looking for the time to go up, then you don't need to double it. Did you get your V0, Connor?
I got 2.94.
Good. Now, the time it's in the air, we can either use the velocity equation, get the time to the high point and then double it, or you can use the distance equation, make your displacement 0 and get that time. Connor, do you have the time?
I got 0.6 seconds. What's
Good. So you can do it either one of these ways. Use your distance equation, and then you get the correct time, or use the velocity equation and double that time. Okay? This gives you the time to the high point. This gives you the time to return to the ground. I'm just going to keep going. I have another 2-dot problem. Tori, is everybody ready to move on?
No.
So we got our time. You can use either one of those equations, the distance equation or the velocity equation, to get your time. Does everybody understand?
Just don't want to written.
All right. I'll just come help you, Connie, if you need help, but we're gonna move on. Is anyone else? Is everyone else done? Okay. Tori, can you please read 239?
The graph in figure
239.
A tennis ball on Mars where the acceleration due to gravity is 0.379 g and air resistance is negligible is hit directly upwards and returns to the same level 8.5 seconds later. How high above its original point did the ball go? How fast was it moving just after it was hit? Sketch graphs of the ball's vertical position, vertical velocity, and vertical acceleration as functions of time while it's in the Martian air.
Yeah, that's right. We did it.
Oh,
Because that's the time. It's not that hard, 239. But the sketches that probably is the hardest part.
So is the V final 0?
No, when something goes up and comes down, it has a speed, right? Write down the variables they give you,
But what should we do?
239. They're asking you the distance to the high point, write it down what they're asking you. Look at your equations.
Is 8.5 seconds a total time, or just what time found?
It says and returns to the same level 8.5 seconds later. So what do you think that means?
The total?
Right, the total time.
What do you know be 0?
Couldn't be 0 and go up and come down, right? So how are you doing? Hopefully this is all coming together. You know the time to the high point is 4.25. You know the time to reach the ground of zero displacement is 8.5 seconds. You know the acceleration is 0.379 times 9.8. You're looking for the delta y. You're looking for v0. Violet, did you get A?
Not yet.
So we're looking for delta y at the high point. What's the time to the high point? I just said it. 4.25 seconds. Connor, did you get A?
It's all right. Did I mess up?
Oh.
I got 1.61.
So you know your acceleration is 0.379 times 9.8. You know the time to the high point is 4.25. You're looking for that delta y. You're looking for v0. And you're sketching your graphs. Okay? And those graphs are the same old. Lincoln, did you get A? How come? You know your time is 4.25. You know your acceleration. You know the speed at the high point is 0. You can immediately get v0. Your v final is 0. Your time is 4.25.
Is it 1.61?
For your v0, it's going to be 15.77. Our final is 0. Our time to the high point is 4.25. You multiply 0.379 times 9.8, you get 3.71.
I don't know how I got 41.65.
I think you did 9.8 for your acceleration.
Oh, yeah.
Okay?
What does it say right there to the left of 9.8?
0.379. They told us that the acceleration was 0.379 g. As you have to pick out these things, if you know it's going to a high point, you know your v final is 0. If they give you the time for the total trip, that means your time to the high point is half that. You can just plug in right away, get your v0. Once you have that v0, then you can get how fast was it moving just after it was hit. That's what we just got. How high above its original point. You don't have to answer it in the order they give you. Now you can get your delta y.
The time is it? We just used 8.5 now.
You're looking for your delta y, so you're looking for the distance to the high point. So what time would you?
Oh, the high point.
Did you get it, Connie? The distance to the high point?
33.49 meters.
Good. We get 15.8 is our initial, 4.25 is our time, minus 1/2, 3.71 times 4.25 squared. How else could I have done this? I could have gone from the high point to the ground.
What number did you use for the gravity?
3.71. That's what they gave us,
Oh, 3.
because you had to multiply g by that. Okay, now notice I could have gone minus 1/2, 3.74.25, and gotten the same answer. Why? Because at the high point, your velocity is 0. So I can take this as, okay, the distance up is the same as the distance down. If I make this 0 and then do this, I'm going to get the distance to reach the ground, which is the same thing as the distance to go up. Okay, you could do it either way. All right, now you're doing your graphs? Let me see your graphs if you're done with them. This is not 0.374. The acceleration is 3.71. They told us the acceleration was 0.379 times 9.8. So our acceleration is 3.71. Okay, you have uniform acceleration. That graph is just a horizontal line. You have uniform acceleration, your velocity graph has got to be a straight line, and you know the slope of that graph. So the slope, you know that.
Do you want us to like put in the numbers for the graph, or do you just want to see like this?
Well, you can put in what is, you can't do that's a parabola. Okay, these graphs look similar after a while. Your acceleration versus time is a flat line with that slope negative 3.71. Your velocity graph should have a negative slope, right? Where that slope,
So is it 3 separate graphs?
yes. Your slope of your velocity time graph is going to be 3.71. It starts at 15.8. So you should have a slope that crosses 0 at 4.25 seconds. So you should have the time it crosses 0, the initial velocity, the acceleration versus time is a flat line with a slope at negative 3.71. This has got to be a parabola. Goes up, comes down. Okay? Everybody understand? All right. We're going to do 41. So hopefully you understand, you got your velocity at the high point is 0. Something goes up and comes down, that's twice the time. The displacement is 0 when it returns to the start point. Okay, so we're gonna do 41. Everybody ready for 41? Lincoln, can you please read 41?
A meter stick is held vertically above your hand, with the lower end between your thumb and your first finger. When you see the meter stick release, you grab it with those two fingers, and you calculate your reaction time from the distance. The meter stick falls. Reach directly from the point where your fingers grab it. A. Deserve a relationship for your reaction time in terms of this measured distance. B. If the measured distance is 17.6 centimeters, what is your reaction time?
So you should understand what's happening. You're just dropping the meter stick and you're catching it. Okay, you just let it go. During that reaction time, it moves. Okay, it's pretty simple. Okay, now if you just go through and write down your equations, you're going to be driving the relationship. That just means writing the equations. So if you solve B somewhere in there, you would have answered A. We're on 41.
You have to turn the centimeters into meters.
It helps, yes.
Since it's being dropped to be zero, the initial velocity would be zero.
It's really not a hard question. I don't know why they make it a 2 dot. You know your V0 is 0, you know the distance it fell. That's a physics 1 question. You show me if you're done. Show me if you have it.
Okay.
Just need to take the square root and divide it down before you took the square root, but you had the right idea. We have this. We know the distance it fell is 0.176. We have 1/2 9.8 t squared, which is minus 4.9. You divide down the 4.9, and then you take the square root. You could have, yeah. Thinking, did you get the time?
0.189.
Good. Okay, so that equation you wrote was the relationship. When they say describing a relationship, you're just writing an equation. You solved the time. You ready for the next one? Let's go to 43. Who has it read? Naomi, can you please read 43?
A 7,500 kilogram rocket blasts off directly from the launch pad with a constant upward acceleration of 2.235 meters per second squared. It feels no appreciable air resistance. When it has reached a height of 525 meters, its engine suddenly failed. The only force acting on it is now gravity. A. What is the maximum height this rocket will reach above the launch pad? B. How much time will elapse after engine failure before the rocket comes crashing down to the launch pad? And how fast will it be moving just before it crashes? C. Sketch A. Time, velocity, time, and Y time graphs of the rocket's motion from the instant it flies off to the instant just before it strikes the launch pad.
This sort of question is in every textbook. They just might have it be an air balloon or something else. Takes off under the influence of its engines, and then the engines fail. Why are they putting it that way? Because you have one acceleration initially, and then it goes into free fall. So when it reaches a height of 525, its engines suddenly fail. The only force acting on it now is gravity. So at that point, our acceleration changes, of course, to negative 9.8. What maximum height will this rocket reach above the launch pad? See if you can figure that out.
Why is it not just 525 meters?
Because when the engine fails, it's going to keep going, right? It's not going to suddenly stop.
Because it constant acceleration. How do you solve for the initial velocity?
They tell you that it has a constant upward acceleration of 2.25. So you should be able to figure it out from that. So you can figure out that initial velocity. You know the acceleration throughout. What else do you know to figure out the initial velocity? What?
The mass.
Well, you don't really need mass though. We don't have mass in any of our equations. But what else can we use to figure out the initial velocity when the engines fail? Well, they didn't give us time, right? What else did they give us that we can use to figure out what that initial velocity is when the engines fail? 525. You know the distance it traveled before the engines failed. And from there, you should be able to figure out the initial velocity of right when the engines fail. So write down what they give you. What's the initial velocity? It blasts off. It accelerates constantly. What's the initial velocity of the rocket when it's launched?
1.25 meters per second.
That's the acceleration.
Oh, wait.
But when it's launched, what's the initial velocity?
It starts from 0.
Right, it starts from 0, accelerates at 2.25, achieves a certain speed by 525 meters. So you know V0 is 0, you know the delta y is 525, you know the acceleration is 2.25. What equation should you use to get that final velocity? The final velocity of that rocket under the engines is the initial velocity of when it becomes a projectile.
But why would it be 0 if it gets blasted off?
Because the rocket starts from nothing and is blasted off and obtains.
Oh,
It's not like when we throw something up and we say it leaves the hand
I
at a
thought
certain
it just
speed.
like shoots a rocket upward.
Well, it does, but it
Yeah.
starts from nothing, and then in that course of that 525, it's progressively increasing in speed. When we say something's thrown upward, we take the speed after it left the hand. This is right from the beginning of the launch. So it starts from 0, goes to some V final.
So it means the V squared.
Use the V squared equation. You don't know the time, you know the initial, you know the acceleration, you know the delta y. You can use the V squared equation to get the V final. The V final for when that rocket is launched. It helps to draw that picture.
What is the?
I drew this picture. So first it goes 525 meters, and it has this acceleration of 2.25. Then right there the engines fail, and then it goes some additional distance under gravity, 9.8. We know that this is 525. We know it started from rest. It goes to some V final. This V final here is the initial velocity for when it's under the influence of gravity. What were you saying, Connor?
So, because instead of 9.8 for the V final squared equation, would we put the 2.2.
Yes, for initially figuring out what that V final is.
Do I just take the absolute value of the V final?
Well, it's going upward. It would be a positive.
So
In the B-squared equation, it's supposed to be the initial square plus or minus.
Your plus or minus goes away when you square it in the equation. But if you're taking the square root of something, that's going to be plus or minus. So we have this, okay? When I take the square root of that equation, it can be plus or minus. So you have to understand, is this going to be plus or minus? Well, it's going up, it's going to be a plus. So what's the V final of for the initial part? Connor, do you have it?
48.61.
Okay, good. Now this becomes the initial velocity once the projectile is launched. When the engines fail, it is a projectile. It was not a projectile before. Anything under the influence of gravity is a projectile. So now this is the initial velocity once those engines have failed. It's a projectile now launched upward. So now you're getting how much further it's going to go. Two times 2.25. Use the V-squared equation, right? Are these zeros? It's 0 plus. Now we're looking to the height it goes to once it's launched from here. Now, how do we want to get the height it goes to?
I use the V final equals the initial. I don't know. The second.
And you got the time?
Yeah.
Okay, so there's different ways you can do it. Once you get that time, then you would, if you did it that way, then you would plug it in. So you could go your time to the high point is zero, your velocity at the high point is 0. And you start with 48.6 minus 9.8 times the time, get that time, and then plug that into your distance equation to get the additional height. That was one way to do it. 48.6 times the time minus 4.9 times squared. That was one way you could do it. Did anyone do it a different way?
Wait, are we trying to find time?
We're trying to find the distance, but this is one way to do it. Did anyone do it a different way? You can also use the v squared equation.
Oh, I'm gonna look on the d squared equation. Like, so is a subtraction in the middle? Would that be a plus?
When we have an acceleration that's negative, it's subtraction. When we have an acceleration that's positive, it's addition. We had a positive acceleration in the last problem when we did the 2.25. That was positive. This one is negative. That one was pointing up. This one's pointing down.
Those first two that you put down, those are for solving for time.
If you're getting the distance, right? If you're getting the distance using the velocity equation and the distance equation, you can get the time and then plug it into the distance equation. Or you can use the v squared equation to directly get the distance. Either way, you should get the same delta y. What's the delta y? Anybody?
Not 120.29.
100 and what?
20.29.
Good. She's significant digits. It's right around 121 meters. Okay, now is that the answer to the question?
Sketch something.
What do we have to do to get the answer to the question? They asked you the distance up from the launch point. So you have to add 525 plus 121. Okay, to get the distance from the launch point.
I've got 645
Okay. It's right around 646 I have. We're using 3 significant digits. Does everybody understand? You could have used your velocity equation to get the time, plugged it into your distance equation, or you could have used the v squared equation to get that delta y. Now you see how you have to do these things on your own at home to really learn it. Try to be awake when you're doing them.
I don't know how I just got the answer. I didn't get 121. I just got 645.5.
In you doing what?
I use the v final square equation.
Use the v final squared equation, the v squared you would have gotten 121. It's just 48.6 squared divided by 19.6. Okay, so for homework, let's see where we left off. We already went up to 34, so we're going to do 36, 38, 40, 42, and 44. Let me give you one more. There's not that many problems, but they take longer if you do them correctly. Let's do 272. Okay, so you just have those 6 problems. Hopefully, you'll all come together. We're gonna do this one more time. We have like maybe another 5 or 6 more problems in the book, and then some more 5 or 6 for homework. And then we're gonna be done with this chapter, and then you have lab and test. So the test will be next week. It will emphasize projectiles.
So the test is gonna be mainly over like this stuff. Right?
Yeah, this stuff.